What's up, Tiger Math Team? This is Anthony once again, coming at you from New York City. I am here to help you with all of your math team related problems or normal math problems. Let me know. But yeah, I am here today to do ICTM question 20, 2007 AA calculator team. And the problem's asking the probability that 3 sticks will form a triangle if one stick is 3 units long, another stick is between 0 and 4 units long, and a third stick is between 0 and 4 units long. So these are the ones that are potentially changing. So you have to think, how could they form a triangle? And maybe why wouldn't they form a triangle? So you can think if stick 1 is 3 units long, then if stick 2 is 0.5 units long, and stick 3 is 0.2 units long, there's no way you're going to get a triangle. So the thing is that whatever the largest side is, the other two sides need to sum to at least as great as this one. So if that guy's 3, you need these other two sides added together need to be greater than 3. If they're exactly 3, you can't really have like an angle here. It would just be like laying on top of each other. So yeah, this is kind of like the inequality that you need to think about. And when you're doing probability in this way, you need to think of, out of all of the options, which ones work and which ones don't. And your probability will be the ones that work over the number of options that don't work. This problem can be modeled in a geometric way because you have a continuous kind of random variable here. So stick 2 and 3 can be between 0 and 4 units long. It's different than if they could be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 in a more discrete way. Then you could just count the number of combinations that work. But here you have an infinite number of combinations. You could have 0.111111112 and 3.11111. There's an infinite number of numbers between 0 and 4. So you probably want to model this probability question like this. One stick can be between 0 and 4 units long. Another stick can be between 0 and 4 units long. So in your denominator, the total number of ways to have 2 lengths for these sticks is 16, the area of this square. And we're going to find what part of this square makes the sticks form a triangle. So obviously at like 0, 0, you're not going to have anything happening. But at like 4 and 4, that one should work. So what's going to cause the triangles to be formed or not to be formed is this inequality. So you can think, if this guy's going to be 3 units long, and you're going to be at 0, this guy's going to need to be at least 3 units long. If you have one stick at 0, the other needs to be bigger than 3. So yeah, we'll see if that works though as well. But yeah, you can kind of think like it's going to need to be at least 3 here and at least 3 here. Yeah, and a potential problem though that you could run into is if you have anywhere between here, like between 3 and 4, and this guy's at like almost 0, this is now the biggest one. So will the other stick at 3 plus almost 0 equal this amount? Yes, you're going to have some limits. So you need to think where in the square is our triangle's going to be made. So at like 1.5 comma 1.5, you know that you're in that situation where you have 1.5, 1.5, they're like almost there. So if you bump it up a little bit in either direction, like these should be good solutions as well. Good. And like these ones are also like almost feasible solutions. So you can draw a straight line this way. And if you think about it, anything in this range is not going to work because the sum of the two sticks, if they're between like 0 and 3 here and 0 and 3 here, anywhere, any of these combinations, the sum's not going to make it to 3. So this is like bad space. Not gonna happen. But in here, good space. Yay. Are there any other spots where the triangle won't work out? Like I was saying over here, if you have like 3.5 and something really small, this is going to be the biggest one, and you're going to have 3 plus something here to get you to this guy. So if this is like 3.5, this one's going to need to be at least 0.5. So you'll have 3.5 equals 3 plus 0.5. So it's going to need to be bigger than that even. So you're also going to get this line here, where anything in this region is bad. You're not going to get any triangles out of 3.5 and anything until 0.5. If you think about it in the edge case, you'll have 4, and then this one will need to be at least 1 unit long, because then you'll have 4 equals 3 plus 1, so it'll need to be bigger than 1. Yeah, and anything in here should work, but you're going to have the same situation with the other stick if you just flip, like one of them's between 3 and 4 and the other one's small. So this also won't give you a triangle. Anything in here will, though. Yay. And you can kind of just like pick some points and think about them, like whatever, if you have 3 and 3.5, is that going to form a triangle? Yes. The sum of any two is going to be at least as big as the third one, or bigger. So you need to divide up this space now and see that, what's the area of this crazy region with the smiley faces? You have 16 minus this triangle is 3 times 3 divided by 2. And these triangles are both 1 times 1 divided by 2. So you're subtracting those off to get this space. So that'll give you 32 over 2 minus 9 over 2 minus 1 over 2 minus 1 over 2. And with that, that equals 32 minus 1 is 31, minus 10 is 21 over 2, over your total of 16. So you have 21 over 2 over 16, which equals 21 over 32, will be your probability of forming a triangle. So yeah, when you have a continuous sort of random variable, or like an infinite number of possibilities, you might want to think about modeling the problem geometrically, like we did here, and just make sure that you're looking over the whole space, that area, which region will form good triangles. So we had to think about what makes a triangle, or like have the ability to be a triangle, which is that little inequality. So, yeah, that was probably explained poorly, but if you have questions, feel free to ask, and I can respond with whatever clarifications you need. Have an awesome weekend. Thanks for watching.